3 toppings. 8 different pizzas. Where does the 8th pizza come from? Pattern 7 of 10 in the NBX STUDIO Dojo, DFS and Backtracking. 3 lines that generate every combination there is and undo themselves on the way back. These signals are the loudest in the dojo because the question usually says them outright. All combinations. Every possible arrangement. Subsets, or the power set. Permutations, where the order matters. Generate or find all, rather than find one. But if the question asks for a count instead of the actual list, dynamic programming is usually cheaper because building a list you only wanted counted is wasted work. That word all is the tell because if they want all of them, somebody has to walk the whole tree. You're building every pizza you can from 3 toppings: pepperoni, mushroom, and olive, which the code calls 1, 2, and 3.
How many pizzas is that?
Each topping is independently on or off, so the count is 2 times 2 times 2, which is 8, and that total includes the plain pizza, with nothing on it at all. People forget the empty pizza constantly, and interviewers notice. Result is the list of finished pizzas. Backtrack is the function that does the walking, and it takes where to start from and which toppings are on the pizza. Now the first line inside, it does something that looks premature. Result, append of current, colon in brackets. Photograph the pizza exactly as it stands. Photographing happens before any topping goes on, which is how the plain pizza reaches the answer, without a single line written specially for it. Here's the whole recipe, and honestly the recipe is 3 lines. Current at append puts a topping on.
Call that the choose step.
Backtrack calls itself and builds every pizza that starts this way. Call that explore. And current.pop takes the topping back off. Call that the undo. Choose explore undo. Say that out loud a few times, because every backtracking problem you'll ever meet is those 3 lines wrapped around a different rule. We put pepperoni on so the pizza is 1 and we photograph it. Notice the call is diving rather than spreading because it isn't looking at the other toppings yet at all. Backtrack calls itself from the next topping along. Mushroom goes on 2, the pizza is 1 and 2, and another photograph is taken. Backtrack goes as deep as the branch allows before considering anything else. Straight from the dojo. The pizza is pepperoni and mushroom. After we try adding olive, what happens next? We're finished. We take olive off, then mushroom, and try pepperoni with olive instead. Or we start a new pizza from scratch. Have a think, and pause the video if you like a moment. Ready? We take the toppings back off and try a different combination because that undoing is the only thing that ever reaches the other branches. Olive goes on, the pizza is 1, 2, 3, the supreme, photographed. No toppings are left to try, so the loop ends and the call returns upward. Current, pop takes olive back off, and we're at 1, 2 again. That loop has also finished, so that call returns 2, and pop takes mushroom off, leaving just pepperoni. We've climbed back up 2 levels, and now the loop at that level can carry on to the topping it never got to. Back at the pepperoni level, the loop moves on to olive, giving pepperoni and olive, a combination we could never have reached without undoing first. This is worth sitting with, because the undo isn't tidying up. Undoing is what creates the other branches. Without that single pop, the pizza just keeps growing until it holds everything, and you finish with 3 pizzas instead of 8. Everything unwinds from the top now. Everything unwinds back to the plain pizza. The loop moves on to mushroom, which gives mushroom, then mushroom and olive, and finally olive on its own. 8 photographs. Plain, pepperoni, pepperoni and mushroom, the supreme, pepperoni and olive, mushroom, mushroom and olive. Return result. Every combination, each exactly once, because the start index means we never walk backwards. One line to be careful about, and this is the bug people genuinely ship. We save current colon in brackets, not current. In Python, a list is a reference, a whiteboard, not a photograph. Saving current itself would leave every entry pointing at the same whiteboard, and since backtracking keeps wiping that whiteboard, you'd finish with 8 identical empty lists. The colon makes a copy for characters, and without them the function silently produces nonsense. Be honest about the cost because an interviewer will push on it. 3 toppings gives 8 subsets, which is nothing. 20 gives 1,000,000. 30 gives 1,000,000,000, and the program stops being usable around there. That's 2 to the n, and it isn't a flaw in your code, because that's the size of the answer itself, which is exactly why a question wanting only a count is a different pattern. For to go and do. Subsets is the one we just wrote. Permutations swaps the start index for a use set, and the difference is worth feeling. Combination sum lets you reuse a number, so the recursion goes to I rather than I plus 1. And n-queens is the famous one, where the undo is undoing a whole board. 3 things to take with you. Your signal is the word all, every combination, every arrangement. Your recipe is choose, explore, undo, in that order, always. And save a copy, because saving the list itself gives you 8 pointers to the same wreckage. Next in the dojo is dynamic programming, which is what you reach for when this tree has the same branch in it over and over. Go and do subsets first, then permutations.